It's good to see you all here again. It's been a long time not to get in touch with everybody. So sorry, I'm so busy. All right, so I will just, do a very quick opening. I was just, okay. Hello, everyone. This is Rick Chuang, and we are very excited to be here to share some exciting updates from our work, from our group. The past few months has been very productive in our lab, and we will walk through all we have been doing. All right. For those who might not know us well, our lab focus on making cities more livable through data analysis and also robotics. In today's presentation, we will cover our human-centric approach to urban mobility, which is our City AI platform, and how we are using robots and AI to transform cities. We will also show how our partnerships are growing as we take on new challenges and strengthen ties with network partners to advance innovative urban solutions. So our partnerships are a big part of what we have been doing by actively engaging with city government, local industry partners, and the network labs. They are our active partners who play a crucial part in pushing our research further. So with their engagement, we are able to test on their environment and also with the community level scenarios. So another exciting news is that we are happy to invite Ran from City Science Guadalajara to work with us on robotic control implementations. This is a good start, and more cooperations will come later. Okay, so I don't think I want to occupy too much of your time, so I will now hand it over to our teams to dive into more details. Thank you.
Hello. Before we jump into the detail of the projects, I just want to give you guys an overview of what we do here, a little bit echoing what we shared during the summit last year, but since now we have some more progress, we try to introduce by showing this diagram as a overall framework that the lab is working on. So we actually started to build the data infrastructure to empower all the projects starting early last year, and we started constantly accumulating more and more data. The good news is that this year we start to have public sectors on board, especially for the Ministry of Interior. They have nationwide very high resolution telco data, foot traffic data, and many other data allow us to do more in-depth research. And we also onboarded some other private sectors to provide more data for their more sort of private proprietary kind of data. So now we enrich the database once and for all, and we also build a lot of things around AI, mostly generative AI, and we adopted this agentic AI framework. We try to modularize whatever we do in the lab, to modularize them and to reuse them, and also to automate all the functions, hopefully, that to empower different applications. And at the very top application level, we have, of course, we have urban analytics. We also have urban robotics. And actually these two, although they seemingly run on their own last year, but we tried to bring them all together starting from this year. And if we see urban analytic more as the intelligence part of what we do, we can see robotics as an actual intervention to the real world, and there's a feedback loop in between. So we are about to share more thing in the project details, and I'll hand it over to our researchers.
Okay, so last year that we share how we leverage large language models to design a large-scale simulation framework. And by utilizing the LLMs, we generated synthetic profiles by establishing the relationships between statistical data. Then agents were then spatially allocated based on various urban contexts. And this year, we further refined the framework to get more comprehensive insights. And we are excited that we have the opportunity to apply it into real-world settings to support urban governance. Next. So earlier this year, we collaborated with a local government to design this framework on a more focused scope to explore how urban data can reveal patterns of citizen mobilities, guide human-centered planning, and facilitate cross-departmental resource integration. We select a district adjacent to two prestigious universities as our study area. So the goal was to simulate the daily mobility behaviors, particularly walking, cycling, and bus usage. So our approach shifts toward a human-centered perspective, highlighting pedestrian experience, uncovering potential risks, and address previously overlooked needs to assist urban planning and decision-making. So to reflect urban patterns, we integrate urban data using the F3 spatial index, and we classify each agent's activities. So right now, the governmental agency can simply switch to a data set relevant to a specific topics or the intersect issues. The platform right now can analyze targeted populations, offering a flexible way to explore pedestrian dynamics across different urban scenarios and to improve the road safety and enhance pedestrians' experiences. So in the following, we're going to present two demonstrations to showcase the potential and the adaptability of this platform.
Okay, so the platform here is the latest version of our simulator. If we want to identify potential traffic accident hotspots, particularly for pedestrian walking to restaurants, we can filter for specific movement patterns and overlay them with the historical traffic accident hex layer. So this allows us to walk through the highlighted routes with experts. And for example, the white line represents a high usage road, while the purple hexagon, especially the lighter one, means that there's have been more accidents happened here within the hex. And the simulated path intersects with the area, suggesting the presence of pedestrian crossing. When going to street view, we can identify a heavily used road segment that lacks a proper zebra crossing. Okay, so this is one scenario. And the next scenario, besides the pedestrian, we also, okay, so we go to the next. Okay, so besides pedestrians, cyclists are also taken into consideration by integrating annual shared by-usage data represented by the orange circles you can see on the map. We can identify popular cycling paths and stations during noon hours. We found that local governments may possess station usage data, but they often lack insights into most frequently used access routes due to the absence of individual trajectory information. So the agent-based simulation can help uncover this popular paths. For instance, we found this popular station next to the night market lacks a proper shadow, reducing the willingness of the usage. So this project is the first implementation in collaboration with the local government in Taiwan. And we also received precious feedback from the experts. Some were amazed by the simulation and were wondering about potential usage on covered sidewalk leveling plan. And also a few experts even hoped the platform could go beyond presenting findings to providing actionable solutions. And currently, we're also working with the BioBio lab using a similar methodology. We look forward to see how BioBio applies this tool to tourism development and hearing their feedback. And next, we're going to show a clever tool related to UN SDGs indicator. I'll hand it over to Yuna.
Okay. We previously discussed how city simulation provide insight for governments and planning through result and standardized data. A city must address not only transportation issue, but also other sustainability aspects. To this end, we collaborate with the New Taipei City government to develop the SDGs indicators mapping system to enhance the efficient and impact of sustainable development. Different cities have varied indicator system and a description. For example, New Taipei City Voluntary Local Review differs from the UN Sustainable Indicators in definition and strata, making cross-city comparison challenge and limit mutual learning and experience sharing. Our solution is to use the UN's 248 sustainable indicators as a universal framework, creating a unified benchmark to promote collaboration and sustainable progress among cities. To achieve indicator mapping, we utilize large language models and word embedding techniques to convert indicator tests into vectors for similarity matching. For instance, one indicator might correspond to multiple UN goals, forming a many-to-many relationships. We use Sankey diagrams to visualize these connections, clearly displaying the coverage and the relationship of indicator. In the end, this enables more data-driven decision-making. Next, we will play a video showcase the 4 features. First, indicator coverage. Overview show coverage rates and cross-city comparison. Next, indicator gap identification use Sankey diagrams to identify unmapping indicators and display data trend. Then, cross-city indicator comparison leverage multi-layer Sankey diagrams to compare indicators across city based on UN standards. Finally, indicator linkage recommendation provides suggestions from open data to fill gaps and encourage cross-departmental collaboration. Let's conclude our demonstration of the SDGs indicator mapping system. In the future, we hope to expand this tool to more cities, further supporting data-driven decision-making for sustainable development. And next, we will gonna show a smart tool focused on urban data analysis.
Before we dive into our latest version, CTAI, I'm going to give you a quick recap. What is CTAI and what is Spatial Temporal Database? Next. The Spatial Temporal Database is a key infrastructure that supports of all our projects. It contains a large amount of uniformly formatted and machine learning-ready data sets. We collect a various types of geometry data, such as tree network in line string format, or land use in polygon format, and apply point sampling to convert the land into a dense set of points. These points were then transformed into the hexagon cells, allowing all spatial attributes to be uniformly stored, queried, and aggregated at multiple resolutions, from city-wide to neighborhood or building scales. As you know, urban data is complex. Questions often require combining multiple data sets, running spatial analysis, and interpreting the results. Traditionally, this process takes time and expert knowledge. That's why we built CTAI. CTAI can help people expose spatial data without any GIS background and help government quickly turn data into insights for better decision making. To solve these challenges, we designed CTAI not as a single AI agent, but as a multi-agent system, which is composed of 1 planner agent and 5 different functional agents. When you send a question to CTAI, the planner starts reasoning and try to understand your intent. Once it's finished, it creates a series of tasks, assigns them to a specific agents, and monitors their status to ensure communication and coordination. These architectures let us handle complex spatial reasoning in real time and bring powerful urban analytics tools to everyone, not just technical experts. Next. And here are some example results generated by CTAI. On the right-hand side images is a result with a neural language input like tell me the average income within a 300 meters of high-speed rail. The CTAI understands the questions, retrieves relevant data, and visualizing it on a map all automatically. And on the right-hand side is more advanced spiritual queries. For example, I'm the development of the Venus Village. I want to select a site with a 15-minute driving radius around all high-speed rail stations in Taiwan. And CTAI dynamically generates the buffer zones, filters relevant data, and prevents the analyze all without requiring GIS experts. And there was a capability of the previous version of CTAI. Now I'm going to hand it over to Shenbu.
Thank you. I'm going to share some of the latest updates we've made to our system. There are three main highlights I'd like to talk about today: the coordinator, the reflection and human-in-the-loop module, and the memory module. Next. First up is a coordinator agent. In our previous experience, we noticed that a lot of users, especially those who aren't familiar with GIS, often unsure how to describe exactly what they need, which makes it tough for the system to give the right answers. That's why we built a coordinator. Its job is to chat with users, ask the right questions, and help gather all the information needed, like which location or dataset to use. So the problem will be clear before moving forward. For example, on the right-hand side, if someone initiates a vague query, the coordinator steps in and guides the user to provide specific details. Next. Second, let's talk about the reflection and human-in-the-loop features. In the past, if our agent made a mistake or misunderstood something, it could mess up everything that followed, and there wasn't really a way to catch those errors in time. Now, after each task agent, such as filter agent, finishes up, the result goes to the new reflection module for a quick check. If things look good, the process keeps going automatically. But if the reflection module notices any issues, it brings the user in right away, so we can make the whole system more robust. Next. The third update is the memory module, which includes short-term and long-term memory. Short-term memory stores all the details within a session and is reset every time to keep things efficient. And while long-term memory only keeps the key results, making it easy to maintain important context through multi-turn dialogue. This complementary design lets users easily ask follow-up questions and continue their analysis naturally. Next. And finally, here is a short video demonstrating these features in action. We follow an elderly care village developer using this platform for site selection. The coordinator recommends relevant data set, and once the user intention is clear, the task is passed to the downstream agent. And here, the data feature retrieves data from our spatial temporal database, such as average income or elderly population count. And next, a human-in-the-loop process enables the user to make adjustments, such as removing redundant dataset here. And the data analyst then analyzes the dataset and extract the critical insight. Finally, the results are handed over to visualization agents like Map Visualizer and Chart Generator. The outcome here is a comprehensive site selection report and a bar chart for value comparison. And lastly, an interactive map with different legends to highlight special patterns. And next. Looking forward, we've got more great features on the way. In the coming months, we'll be introducing a time series analysis module and launching a new data science agent with prediction capabilities. making it easy to track trends and forecast future changes and gain even deeper insight. And finally, we are redesigning our front-end interface to make maps easier to read and use. Now I'll hand it over to robotics team to share their exciting updates.
Okay, thank you, Ian. So with the fundamental infrastructure that we just introduced, we leverage AI modules, agentic AI, and multi-agent frameworks to support our robotic initiatives. According to the World Bank, in 2025, an estimated of around 700 million people worldwide are living in extreme poverty. So they survive in less than $2 per day, and this represents 9% of the global population. So to give you all a sense of the diverse urban challenges we're addressing, cities like Concepcion, Mexico City, Hamburg, and Taiwan. So we're not building robots. We're not actually not building robots like these Terminators. We're actually building robots, and urban interventions focuses on transformative applications. So like last meter delivery robots to ensure seamless logistics in cities, bionic robots acting as environmental spies to monitor our ecosystems, educational robots for teaching students, and assistive robots to design to support humans with tasks like entering difficult terrains and elderly care. So these robots are our partners in building more resilient communities. And next, I'll pass on to Michelle to learn more about our urban delivery robots.
Thank you, Evelyn. Then let's talk more about the urban delivery robot that we had mentioned before. That slams are densely populated with urban settlements that often lack of basic infrastructure like paved road, clear water, and reliable electricity. And especially that's very difficult for them to access the traditional delivery system, which you can see that the traditional one is using a van or truck, then it's hard to navigate through the narrow and uneven pathway that slam usually have. And next. So we had a bipedal robots that you can see from the videos that can navigate through flat floor, and also it has the ability to overcome the uneven surface. And we want to implement this robot for the last meter delivery through the difficult environment, perhaps like SLAM. And for this, we also wanted to enhance the ability for these bipedal robots. So we developed a docking system to larger the ability for loads and even for other applications to travel through the more complex urban environment. And later on, Morris will introduce what we had invented for our quadruped red dog.
Oh, so first we will show a video that we test our quadruped robot in front of our lab. As you can see, I think most of our city residents show the same reaction as the dog in this video. Kind of frightened when I first saw a robot walk on the street. And so we want to build a robot to assimilate into our society more smoothly. So next. I'm gonna introduce our bionic robot, and we hope it can be like an application robot for everyone to use. And next, please. Oh, so it requires it has some mobility, and it can just move around at our environment. And beside it, next please, thank you. And because it equipped with a stereo camera and at its head, so it can do some simple navigation at our home environment, and with Apple Tech to collaborate its location. Okay, next, please. And the next project I'm gonna introduce is a red dot. And so we hope it can cross more complex terrain in the city environment. And so this is a few video that we use reinforcement learning to train our red dot in the simulation environment and powered by NVIDIA Omniverse. So when we train, it's like you can move around at a simulation environment. And next will be another video sent from using reinforcement learning to train it at a more complex terrain. Yeah. And next, please. So this is the true robot, real robot that deployed our policy that we train from our simulation environment. So as you can see, it can just do some move around at our home environment. Yeah. And the next project that we work with Huang from City Science Lab at Guadalajara. And so we try to let our robot can walk more bionic. So we're trying to build a bionic spiral gate. So we just like get the gate pattern from the animation, and we record the gate trajectory, and then we optimize it, and finally we just do the training, same using reinforced learning. So next please. So like the right-hand side is the animation that we collect from the Unity. And the left-hand side will be the gate analyzed. And next slide, please. So as you can see, these two videos are compared to we do the optimization and after we do the optimization. So as you can see, the performance will be better after we just do the optimization. So the next one that we do at the same at the go-to that we have at our lab. So it shows and we try to randomize the linear angular velocity command to make it more robust. So at the end, I want to hand over to Evelyn to do the conclusion. Thank you.
Okay, so to conclude our presentation today, so we highlight some of our impactful partnerships, and with city government such as Hsinchu City Government, we focuses on the local scale projects where the university is located at, simulating and analyzing students and faculty's mobility pattern to identify high-risk intersections and address the pedestrian safety and walking demands. And with New Taipei City, we collaborate with them to develop an open and interactive platform that enables citizens and government to jointly review the city's sustainability progress by aligning their VLR, which is the local voluntary reports, with the United Nations SDG goals. We're also exploring community scale environments by leveraging multiple forms of robots as our platforms. We're looking into human-robot interactions and future applications in urban context. So this wrap up our presentation today. And thank you for joining us. And we'd be happy to open the floor now for questions and discussions.
Thank you.
All right.
Thank you, everyone.
Yeah, Mike Tony, maybe I can start with a question. First of all, again, I'm really impressed by the range of work that this amazing team in Taipei is doing. Very impressive. So thank you all for, and it was a really nicely organized presentation. Everybody was on topic and concise and good graphics. I mean, it was really, really great. Thank you. I want to ask a question about, and you may not have an answer to this, doesn't matter. It's a question that I'm grappling with, we're grappling with at MIT. See if you have any thoughts on this. Maybe this is a question for Roy and Michael. Maybe you two can chime in. So we're working on several new city projects, and these are challenging because unlike an existing city, there's no data because the place doesn't exist yet. You know, you don't have road networks and traffic data, et cetera, to analyze. And, you know, it seems to me there are three things you have to do to model these new cities. You have to have good demographic profiles, you know, profiles of the people who will live or work or visit in a place, and, you know, and their complex goals and behaviors. And, you know, I think the LLMs are a great tool to help get a lot more nuance and complexity into that. I'm not too worried about that. You need a good agent-based model, number two, that can simulate all these activities, you know, where people go, the modes they choose, where they gather, and how they might respond to light and views and environmental qualities and form relationships eventually and react emotionally to their environment and other people. I think we're making good progress in developing these ABMs, and you all talked about that. Seems to me the bottleneck is how to build a high fidelity three-dimensional model of a place that doesn't exist, that has all of these fine-grained amenities and the types of gardens and the urban design features and noise levels, artificial lighting. I mean, there are all these things that a real world has that are not in the kind of three-dimensional models that architects and urban planners make. So I guess the question to you all is, how do you think we can innovate in building these high fidelity three-dimensional virtual worlds? And how might you know, AI and these large language models and other generative tools help us build these rich three-dimensional worlds? And some of these you can, you know, the gaming industry is building are really quite rich, so that agents can make these contextually informed decisions about their activities. It seems to me that is one of the biggest challenges that we're facing. So Roy, give me the answer to that.
I may not have a perfect answer for that, but we are actually something that we haven't shared because we're still working in a more like an experimental way. We are using something that's actually more agent-based at the local level, meaning you have multiple could be people, virtual people or virtual vehicle, and they would it's more like a game engine that you could send a command, have them all head into some places, and they will avoid each other. It's a very typical three-dimensional agent-based modeling mechanism, but we try to connect that with maybe large language model to generate something similar to our what we're implementing in Taipei, which is a much larger scale, almost like a two-dimensional kind of canvas, but using a large language model to generate from the profiling different demographics all the way to their itinerary, and hopefully to do a more dynamically self-adjusting kind of feedback loop. So you have agents, almost like a human actual human behavior. You plan to go to a movie theater, but there's a crowd over there, so you decided to take a detour. Something like that is a decision chain, but it reflects the real situation almost every second or every minute you renew your itinerary, then you send to that simulated environment. So we're exploring the possibility of that. And that is more like an interior level granularity and three-dimensional. And yeah, but that's still in the early phase. So we don't have much to share, but hopefully we can implement that. And we hope to work with Taipei City government on some selected sites, which is still in a very early phase. We were still discussing about that. But if that happens, we will have designated sites, which again will be three-dimensional at a high granularity, because we were building 2 major new buildings, and there's underway going through, and there's my bridges coming out. So it's actually it's literally a three-dimensional, and it is for future. It's not built yet. So we try to implement that onto that kind of site. So if that all happens, I think that will partially answer to your question, Kent.
Right.
Yeah.
Well, but no, I see where you're going with that. But if you have that movie theater and it's in the three-dimensional model, then somehow the agents need to know that there's a performance from like 8 to 10 in the evening on certain days, and it draws so many people, and is it an opera or is it a techno club that would draw young people? In other words, these three-dimensional models have to have a lot of data in order for the agents to respond to it. Michael, you're working on a three-dimensional model right now.
That is correct.
So maybe
Yep.
So how are we going to get this kind of rich information into these virtual worlds?
Yeah, so Ken, I think that eventually, as the presentation flow goes today, we start from the urban data analytics and goes to robotics. Morris was showing the development in the Omniverse using it to train the robotic, using RL to train the robots in the simulation environment. So Omniverse actually provides, like NVIDIA Omniverse actually definitely provides a very good physics simulation system that allows us to do more. Also beyond just training the robot. So I can totally see the possibility building a high resolution 3D environment in the Omniverse environment where you have a real-time ray tracing and all that. And then, so that's actually the approach that we're trying to do to merge the research between the robotic team and also the data analytic team. And then, so for Roy and his team, the team he's leading is actually collecting data, understanding what's happening in the city, getting the proper infrastructure, the backend, and the APIs, and also the front-end visualization. And that's actually the foundation of this 3D model, high-resolution 3D model. The team is actually constantly collecting the real-time point of interest, the real point of interest from the Google map, using the simulated population to walk around in the environment. And that would be a large language model could allow us to output and providing every virtual agent in the high resolution Omniverse 3D environment to act more like a human behavior. And then so the question that we always ask is actually what data to collect, what simulation to run, and what AI model to build. But also, Ken, from the MIT point of view, I think asking the right question is always the foundation of a meaningful research. And then this is the part that we have all these weekly meetings, trying to ask the right question, like what are we trying to do? I think this is the beauty of this network that allows us to share what we have been doing and then listen to everybody. So one keyword that always shines in our mind is this hyperlocal solution for global problem. How can we share what we learn? And some experiment, like the experiment in the Omniverse, we're actually working with Huang, and then with the aim to build the digital twin in the informal settlement for Guadalajara. And then, so that's actually making me really exciting, because in the informal settlement, the terrain will be different. The behavior would also be different. And then we could train the robot to understand the informal settlement, but also we can build the agent-based system for the informal settlement as well. And that would allow us to explore the territory and the behavior beyond the current city that we have data. and that goes to the the areas that we don't have data. We're not quite there yet, and then but it's a lab, right? And so we do step by step. I think Roy is doing a great job leading the team. So is Evelyn, and then in fact I purposely not to involve in the presentation, but I think it's been a great pleasure for me to work with the team in Taipei, but also working with Johnny and some of the MIT team like Johnny, and then are actually working closely with the team in Taipei, and we're hoping to bring more as well. Does that answer your question, or I just speak too much?
Yeah, it's getting there. I think this is a question we'll be asking for many months in the future. Yes. Well, let's see. Marcus has his hand up.
Go ahead, Marcus.
Yeah, I got it. Sorry. Great work. Thank you very much for the presentation. Just to add to Ken's question, I always struggle with this question as well around how do you create the granular urban context that facilitates these great experiences in London or Taipei or whatever. And I always feel like one way these large language models could help us is to say, well, if you have to have a starting point. So if you're going to say this is the population group, like, young entrepreneurial tech workers, and then you try to extract what are the land uses they use, and you put that feedback loop into the built environment or into the virtual environment that says, well, they need a Gap store, or they need an Apple store, or they need, one for this. So you create this kind of like loop that allows for you to get programming from population. I don't know if that seems doable or possible, but I kind of feel like the disbalance between demographic population that's going to be hosted in the virtual environment, and then the land uses that are needed for their better experiences, whatever,
Nope.
This is a question, if that's a viable loop that could be talked about.
Yep.
Maybe I'll just jump in a little bit on that one, because we've been thinking about modeling this spatial temporal complexity of cities. That includes who, where, doing what, and all the programming essentially of the entire city. That takes tremendous effort. That means we need to build a learning, or essentially a new type of model, new type of token. Let's say it would be totally different from the large language model, and that's more like a hardcore science and data science kind of work. But that's something actually a lot of entities, including ourselves, are trying to do. Since we collect more data, we really want to break down, we really want to decode the complexity of all this interrelationship between people and things and programs of the city. So that could be done theoretically by deep analyzing the existing cities and superimpose that to an unbuilt city. Yeah. But how much that holy grail is created, how much it is like suitable for that particular site, that's a pending question though. So that's my quick thoughts. Yeah.
No, super interesting. I mean, it's something that I'd love to explore more. If you start that thread of discussion, please include us.
Mayra?
Hey, Mara.
Hi, everybody. Well, great.
Hi.
Thank you for the presentation. It's great. And I was wondering regarding this analysis and implementation of robotics in informal settlements for collecting data or also for delivery. It's been a long time that I was thinking that we could use these drones or robotics to implement in the circular economy within the informal settlements. It's something that we have been thinking about, but we had not started in, working on that or developing a prototype or something that could help us maybe with the eco-technologies and all these things that we are trying to implement in informal settlements for the people to produce their own, inputs to generate or to improve their economy, like the dehydrator or the things that they could get from the orchards or the bakery, all these products that they are making within the informal settlements that they could sell into a neighborhood which is next to them. And we have this issue that high-income neighborhoods are located very close to low-income settlements. So there is a short distance that you can travel, but the topography, is complicated, and the infrastructure, as you mentioned, the conditions of infrastructure and services that make this accessibility, inexistent, that we have this type of issues. And also security, because we were thinking, okay, but if we fly a drone and maybe somebody should shoot it down, so what should we do, So there are a lot of challenges and concerns that, we have to deal with, but it's something that we have in mind, and we have been thinking how could we, figure out solutions for these challenges. And maybe it's something that we would like to work with you, that you have this experience, the technique, and maybe we have the land to explore solutions. And it's something that we are interested in also in exploring. And I don't know, Michael, if, last time I speak to Juan Rodolfo, which is one of our colleagues that he's doing his PhD in Carnegie Mellon. He told me, he's going to do this stay with you during the summer. And I think that's going to be concrete in this year, this summer. So I think that will be one possibility to explore while he's staying with you. Maybe we could work on this project together, or we have to talk about it, but it's very exciting, and we would like also to strong this collaboration with Taipei as well. Thank you very much for your presentation.
Michael, you're muted.
Yeah, thank you, Mara. When I speak with Huang, we talked about projects, we talked about how we're gonna do things together, and then we talked about making the project fun, involving the students, and then sharing the toys, the robots to Guadalajara to map the environment, get people excited. But we left out the purpose. And I think what you just mentioned is actually a purpose for this project. And then I'll definitely continue talking to Huang, because I told Huang that this should be a joint project between Guadalajara and Taipei. And it's not the Taipei Tech project, it's our project together. And then so having your involvement and then your insight about the local wisdom will definitely enrich the project and giving the project a sense of purpose. And then so while you were talking about it, I feel so ashamed. I was like, I never thought about the purpose of the project. We just thought about, we need to work together and we need to make it fun. And then, but this is a perfect timing that we'll definitely continue talking to Huang. And then next time we'll invite you to invite your team to be part of the meeting as well. Yep.
Yeah, great. Thank you.
Yeah. Yep.
Okay.
But also Roy has been working with San Sebastian. No, with our labs in Chile, right?
Oh yeah, with Bill.
With Bill, yeah.
Actually just started with Diego's team.
Yeah.
We don't have much to share though,
Yeah,
but
Diego.
we will definitely have something to share by the summit. Yeah.
Nice. Okay, more questions? We still have 5 more minutes. No?
I have another question.
Okay.
Sorry. At the beginning, you were talking about the SDGs and the evaluation metrics with all the Sankey diagrams. Like, how are we benchmarking those across different environments? Like, is it different in Taipei than it would be in Guadalajara, than it would be in Chile? Like, where is that benchmarking coming from for good or bad?
Ian, you want to do this? Simple.
Okay, we just collect the data from the local volunteer review and the textual data, and we use embedding model to embed in the words and make the UNs as a standard, and we matching the indicator into this benchmark and calculate the similarity, and we set a criteria if the threshold is higher than this criteria, and then we think they are similar enough, and we mapping that together. But this criteria is set by us, so it's not just it's hard to say that it's a good criteria, I think.
Let me add something to that. Actually, we avoid to do any subjective judgment. We are not there to say this city should consider this and that. We are not the judge, and we are not in a position to do anything like that. But instead, we use word embedding techniques to pull, on one hand, the UN indicators and the local reports, try to match them. And also, our mapping system is merely mapping the accuracy, or in whether or not they are covering the right sort of percentage of the entire UN and indicators. And also we examine over the year whether or not the local city has performed on a sort of a positive trend, and we just review the overall trends and overall similarity mapping result. We avoid to do anything on our own to judge the city, because yeah, again, we're not in a good place for that. But hopefully this sort of converter can help cities start to be able to compare with each other. I think that's the whole point of doing this mapper tool. Yeah.
Yeah, no, super interesting, because that's a real problem across, like, some of those metrics will be different in Taipei than they would be in Cairo.
That's correct.
Yeah.
Success would look different.
Yep.
And that's the real hard part across different environments.
Yeah, Marcus, so we look into the local volunteer report, VOR. The VOR report basically describes what the city has done locally. Every city is different, the context is different, so they have the local index.
Right.
And Taipei could compare to Taipei City because it's similar context, similar location. But when Taipei compared to Paris, it's probably not right.
Not apples to apples.
So apple to apple, and then so that allows the new Taipei City to see what's missing and what have we done right and what should we emphasize. And what's really interesting is that when I was meeting with all these politicians, they talked about the index, the metrics. We've all talking about why. But every index in the SDG actually tell you why this is important. There's a vision attached to it, whether we agree or not. At least as a beautiful statement. And then why are we doing this? And then so having this platform allowed every government employees to review their own work. I'm actually doing good things for education. And then what else is actually connected is really close to what I'm doing now, and that could amplify, all the work, and how can we learn from other people. So I think the most important thing is actually apple to apple compare with local city, local city to local city, and we can let them compete. And this is why we create this platform to allow the city to examine what have they done.
Gotcha.
Okay, so right on time. Thank you, Taipei team, for the great presentation. Good night Sorry for
Yeah.
and thank you for being so late with us.
Yeah.
Thank you everyone for coming, for attending the meeting. Have a nice week. Enjoy the good weather, and see you in a month, like June. I think the next meeting will be in June 24. So we will send you all the information soon. So yeah, see you. Bye.
Thank you.
Thank you. Thank you very much.
Thank you.
Bye.
Bye, guys.